Hi, Assalamualaikum. My name is Muhammad Afif bin Muhammad Yusuf from class DAD 1A.
Assalamualaikum. My name is Muhammad Mukris bin Hasni. My metric number 05DAD 20F1037.
Hello, my name is Muhammad Muklis Zufri bin Effendi. My metric card number is 05DAD 20F1043.
Hello, my name is Mama Ishad from class DAD 1A. My metric number is 05DAD 20F1040.
Hi, my name is Azri Abadi and I'm from DAD 1A. My number metric is 05DAD 20F1049.
Hi everyone, my name is Ferdinand Sere Anaugat. My matrix number is 05DAD 20F1046 and I'm from DAD 1A.
First, I'm gonna talk about welding defects. Most defects encountered in welding are due to an improper welding procedure. Once the causes are determined, the operator can easily correct the problems. Defects usually encountered include incomplete penetration, incomplete fusion, undercutting, porosity, and longitudinal cracking. Weld defects are often caused by improper technique or parameters such as poor shielding gas, cover coverage, or incorrect travel speeds.
So the first defect is fish eye. These defects are silver gray parts of fish eyes, which appear in the fracture parts of weld metals. They are produced when moisture absorbing electrodes are used and cooling rate is too fast. How to prevent the fish eye is 1. We have to avoid rapid cooling of weld metals. Second, do not use the electrodes which absorb moisture. 3. Use the low hydrogen types of electrode. And 4. Pro-heat the job.
Cracks of weld metal. There is no one kind of crack which is caused by shrinkage of metals accompanying cooling of metals. When the properties of steel's resistance of joint and shape of bed are inferior, or when the cooling rate of weld metals is too rapid or impure electrodes are used, these defects are liable to arise. Prevention. Number 1. Do not use excessive current. Number 2. Avoid rapid cooling of weld metal. Number 3. When the rigidity of joint grade, preheating and pinning is required, as another method is considered to change welding order. Number 4. Select the electrode suitable to base metal, especially when Si and C are rich. Use the low hydrogen type electrode. Number 5. Do not use the electrodes which absorb moisture. Inclusion of slags. These are the defects are the condition that the slags are included in the weld metals or between weld metal and the base metal. They are produced when the welding current is low, speed of manipulation is improper, and groove configuration or root interval are improper. Prevention. Number 1. Raise the welding current. Number 2. Operate with proper welding speed. Number 3. Widen the root interval. Number 4. Select the proper electrode.
Okay, let's move on to overlapping. They are produced when welding speed is too slow, at the state that weld metals does not melt with base metal sufficiently and weld metal put over the surface of base metals. So, prevention. The first one is use the correct welding current. The second one is use the correct manipulation speed. The third one is select the proper electrode. So let's move on to undercutting. These defects are deeply cutted groove. When welding current is too expensive, manipulation method of electrodes is improper and they are liable to occur. So, prevention. The first one is use the correct welding current. The second one is select the proper manipulation speed. The third one is avoid the excessive heating of base metal. And the fourth one is make the arc length proper.
Occurrence of blowholes. These are two types of blowholes, one which arise inside of weld metals, the other rise on the surface. If a length is not proper, excessive current is used. Dirty or inferior base metal is adopted and improper electrode is used. These defects are liable to occur. Prevention. 1. Use the correct welding current. 2. Make the arc length proper. Remove the rust, oil and moisture which adhere to the base metal. Use the correct electrode.
So now let's move on to the second one, which is introduction for distortion in welding. What is distortion? Distortion is any unwanted physical change or departure from specification in a fabricated structure or component as a consequence of welding. So let's talk about angular distortion. Weld tends to be wider at the top than the bottom, causing more solidification, shrinkage, and thermal constriction. For double V, edge butt weld joint, it depends upon root, face, and root gap. Fillet weld joint, it depends upon flange thickness. Depends upon type of joint, weld pass sequence, thermomechanical material properties, width and depth of fusion zone relative.
2. Longitudinal shrinkage. Shrinkage in the direction of the weld axis. Cause preheat or fast cooling problem. Shrinkage stretch in high constraint areas. Prevention. Weld toward areas of less constraints. Weld short length. Preheat to even out the cooling rates. Straightening press jacks clamps should be used. 3. Transverse shrinkage. Shrinkage running into or inside a weld. Transverse to the weld axis direction. Cause weld metal hardness problem. Constraints apply to weld joint.
Transverse shrinkage. Number 1. Boot welds is 1.5 to 3 mm per weld to 60 degrees V joint depending of number of runs. Number 2. Fillet weld 0.8 mm per weld where the leg length does not exceed 3 per 4 plate thickness. Number 4. Rotational distortion. In this, sheets being butt welded either come closer to each other or the distance between them is widened. Depend upon thickness of parent material, temperature difference between a molten pool and the unheated parent, speed of welding, and heat source.
Fifth one, bowing or longitudinal bending. Weld line does not coincide with neutral axis of a weld structure. Besides, amount of distortion depends on shrinkage, moment, and resistance of the member to bending.
Twisting distortion. Twisting is due to low torsional resistance on thin materials. When a weld is made along the center of a member, the welds tend to shrink and become shorter. Buckling and twisting distortion prevention. Minimize shrinkage by decreasing volume of weld metal and highest compatible speed. Keep the length of the welded member as short as practical. Incorporate torsional resistance to twisting as much feasible.
So, how to minimize distortion? First, do not overweld because the more metal placed in a joint, the greater the shrinkage force. Correctly sizing a weld for the requirement of the joint not only minimizes distortion. The amount of weld metal in fillet weld can be minimized by the use of a flat or slightly convex bed, and in a butt joint by proper edge preparation and fit up. Number 2. Use intermittent welding. Another way to minimize weld metal is to use intermittent rather than continuous welds where possible. For attaching stiffeners to plate, such an example, intermittent welds can reduce the weld metal by as much as 75%.
So let's move on to the third one, which is use as few weld passes as possible. Fewer passes with large electrodes are preferable to a greater number of passes with small electrodes. Shrinkage caused by each pass tends to be cumulative, thereby increasing total shrinkage when many passes are used.
Number 4. Place welds near the neutral axis. Number 1. Distortion is minimized by providing a smaller leverage for the shrinkage forces to pull the plates out of the alignment. Number 2. Both design of the weldment and welding sequence can be used effectively to control distortion.
Balance weld around the neutral axis. Offset one shrinkage force with another to effectively minimize distortion of the weldment. Design of the assembly and proper sequence of welding are important factors.
6. Plan the welding sequence. A well-planned welding sequence involves placing weld metal at different points of the assembly so that as the structure shrinks in one place. An example of this welding alternately on both sides of the neutral axis is in making a complete joint penetration.
Pop